All right, hello again. In the previous lesson, we solved quadratic equations, or excuse me, quadratic equations using the quadratic formula. And we used things like factoring, square roots, and the quadratic formula, and also the discriminant. Now, in this lesson, we want to work with things like complex numbers and quadratic applications. So let's begin with some quick rules. Some quick rules in this lesson are I stands for the square root of -1, and I squared stands for -1. The square root of -a is equal to I square root of a, or a is greater than 0. Just for the record, this -a is the same as having a -1, right? The -1 is essentially I, okay? Just for the record. Um, then we have complex solutions occur when the discriminant is less than 0. We talked about that briefly in the last lesson. In in applications, answers must fit the context of the problem. Okay, so very, very important. So let's look at example number one. Example number one, simplify each expression. We have the square root of -49, and we have the square root of -18, and the square root of -75. Okay, so let's start first of all with A. Since -49 has a negative inside the square root, you have to separate the negative part. Okay, so we have -49, and we're going to separate those parts. We're going to make the +49 multiplied by the -1. Okay, some people like to put this in parentheses and can, okay, as it's shown here. Okay, excuse me. Okay, so this separates, which leaves us with the following answer, which is this is 7, and this, as we saw earlier, was I. So this final answer is 7I. Okay, final answer. Okay, so that's A. B, we have the root, negative root of 18, negative root 18. Do the same thing here. Negative root 18 and separate the two. So we have -18. Now, it's very important because this is going to run into something called factoring. I like to refer to this as the factor tree. Because when you have a number like 18, 18 is not a perfect square. So we're going to have to factor that eventually, all right? So when we simplify this, we want to, first of all, separate the 18 from, we already know this is going to be a -1, okay? So we can kind of leave this to the side for a moment. But let's think about the 18. So 18 in factor to 9 times 2, right? Okay, that's very important. Those two numbers multiply to give me 9. Uh, those two numbers multiply to give me 18. Now notice, if I were to put the square root around this, notice one of them is a perfect square, so I can simplify it, okay? So that's exactly what I'm going to do. So I'm going to square, so I got 9 and 2. So think about two numbers that multiply to give you 18. Then I have the square root of -1, that's going to follow. And then notice I can take the square root of both. If I take the square root of 9, I'm going to end up with 3. And then meanwhile, this 2 is going to stay in the radicand. So I have 9 times the square root of 2 times square root of -1, like that. Continuing on, this simplifies to 3. Root 2 times a. And I'm just going to go ahead and simplify that now. So the final answer is going to be 3I root 2. Okay, 3I root. Okay, so just for the record, you can simplify imperfect squares, right? C. Now we have the square root of 75, -75. So we have -75. We're going to do the same thing. It's not a perfect square. So we can separate it, or excuse me, 75 times -1. We know that this is going to be I. Now, two numbers that multiply to give me 75. We have 75. We can do 25 times 3. Notice we have one perfect square, and this is going to be 5. Okay, so simplifying this, we have square root of 25 times the square root of 3. This simplifies to 5 root 3 times I, final answer, 5I root 3. That's it. Okay, now let's continue. Example number 2. Example number 2, solve the quadratic with complex solutions. So we need to solve x squared plus 6x plus 3 equals 0. Okay, and give the solutions in a plus bi form. Okay, so what we're going to do is we're going to use the quadratic formula. All right, we need to identify parts. So we have a that's going to equal 1. X has a coefficient of 1. And we have b, which is going to be 6, and c, which is 13. Now we're going to substitute into the quadratic formula. The quadratic formula is x equals b, negative b plus or minus square root of b squared minus 4ac divided by a. Okay, I'm just going to write right through. So we have negative b squared, which is going to be negative 6 plus or minus the square root of 36, right? Because we have 6 squared, 36 minus, let's see, 4 times, let's see, negative 4 times 6, excuse me, negative 4 times 1 times 13. So that's, it's going to be minus 52. And we're going to divide by 2 times a, which is 2. Okay. This will get us, let's see, um, negative 6 plus or minus square root of negative 16 divided by 2. Okay. Now, since the square root of negative 16 is essentially 4a, I mean, excuse me, 4I, right? So this is 4I, right? Negative 16, 4I, easily establish that. Then that, this is essentially saying that we have negative 6 plus or minus 4I divided by 2. And now we divide uh, both terms by 2. And thankfully, it simplifies very easily. So we have negative 6 plus 4I divided by 2, which is going to give us negative 3 plus 2I. Then we have negative 6 minus 4I divided by 2, going to give us um, negative 3 minus 2I. Okay, we have both of those x values. X is equal to this, and x is equal to this. And again, these are called complex conjugates. Okay, complex conjugates. Okay, now pause the video and try the problem at the bottom. All right, so in this problem, we have 2x squared minus 4x plus 5 equals 0. State whether the solutions are real or complex. So first of all, we need to identify our parts. We have a is 2, b is negative 4, and 5. Okay, using that information, we're gonna put it into our quadratic equation, quadratic formula, plus or minus b squared minus 4a divided by, okay, so we have negative negative 4 plus or minus the square root of b squared, which is negative 4 squared, minus 4 times 5 divided by 2 times 2. And I'm just going to simplify this right out. I know for a fact this is going to be 4 square root of negative 24 divided by 4. Okay. 16, that's 20 times 2, that's 40. So that's, you subtract them, they're going to end up with a negative 20. Okay. Now we can simplify this right here, right? 24 simplifies easily to, we take the square root of negative 24. We know that this is essentially I 24, right? So if it's I square root 24, can we do anything to that 24? Let's see, 24 square root 4 and 6, because we can simplify the 4, not the 6. So this will allow us to simplify further. We can't use 12 and 2. We can't use 8 and 3 because those are not perfect squares, but we can simplify it using the 4 that you see here. When we simplify that, we're going to end up with 4 square plus or minus, let's see, it's going to be 2I root 6, okay, divided by 4. Now let's reduce the term, okay? So we can reduce the term here, right? We can say, we simplify this. We're going to, because the 4 simplifies to 1. So essentially, one solution is going to be x is equal to 1 plus, if I simplify this, this will be, that'll go down to 1 half. So it'll be I root 6 divided by 2. Okay, that's one solution. Notice the complexity of it. Okay, so I simplified it and simplified 4 over 4, which is going to be 1. Then I simplified this 2/4 simplified to 1 half. Okay, then the other value is going to give me 1 minus I root 6 divided by 2 as well. Okay, notice I don't have to put the 1 there, it's just kind of implied. All right, let's continue. All right, part 4, example 3. Okay, a ball, this is a projectile application. A ball is launched from a height equation of ht equals negative 16t squared plus 48t plus 4. Find the time when the ball hits the ground, round to the nearest tenth. Okay, so the ball hits the ground when the height is 0, clearly, right? So we set ht equal to 0. We have negative 16t squared plus 48t plus 4 equals 0. Because when the height is 0, that's when we know it hits the ground. So using the quadratic equation, we have a is equal to negative 16, b is equal to 48, c is equal to 4. So we substitute that information into, since we're looking for, since we're gonna use we're thinking about time, so we're gonna use t instead of x. So t is equal to b squared, which is negative 48, excuse me, negative b, which is negative 48 in this case, plus or minus square root of, c b squared, which is 48 squared minus 4 times negative 16 times 4. Then we're going to divide that by 2 times negative 16. Okay. Simplifying this, we're going to end up with t. T is equal to negative 48 plus or minus, let's see, 48 squared. 2,304 gonna add because it's gonna be a positive 200 divided by base negative 32. Simplifying this further, let's see, negative 48 plus or minus root 2,500. Okay, then we're gonna divide that by. Okay, so this is gonna give us two values, right? So this gives us two values because of the plus or minus symbol. Um, so it is also equivalent to, okay, simplify this, you'll end up with 3 plus or minus square root of 10 divided by 2. Okay, so what we're going to end up with is two values from this. We have t is equal to 3 plus root 10 divided by 2, approximately 0.1. Then we have t equals 3 minus root 10 divided by 2, approximately negative 0. Okay. So since time cannot be negative, right? It cannot be negative 0.1 context. So we're going to reject this value. So the final answer is approximately 3.1 seconds. Okay. Now, example number 4. For ht equals negative 16t squared plus 64t plus 5, find the time of the maximum height and the maximum. Find the time of the maximum height and the maximum height. Okay. All right. So this is a quadratic. This is a quadratic model, obviously. I don't find the time of the maximum. Okay, no, it's not a typo. So find the. We're looking for the time and the maximum height. So we're looking for two things: time and the height. All right. So this is a quadratic model. Since a is negative, the parabola is going to open down. Right. This is a negative a. So the maximum occurs at the vertex. Remember, we looked at the vertex. Vertex is negative b divided by 2a from previous lessons. So the time of the vertex is equals negative b divided by 2a. So again, this is going to be a, b, okay. So negative b be negative 64. In this case, I have negative 64 divided by times a, which is 60. That's going to give me positive 2. 64, negative 64 divided by negative 32 is going to be positive 2. So the maximum height occurs at 2 seconds. Okay, that's the maximum height, or t equals, okay, so that's the maximum height. Now let's write h, substitute the 2 in there. That's going to be negative 16. 2 squared plus 64 multiplied by 2 plus 5. Negative 16 times 4 plus 128 plus 5. Negative 64 plus 133 equals positive 69. Okay. So H at 2 seconds reaches a maximum height of 69 feet. Okay. So the time of maximum height is 2 seconds, and the maximum height is 69 feet. Right? Let's continue. All right. So a common mistake. A quadratic application gives t equals -1 and t equals 5. Explain why t equals -1 is rejected in a time problem. Okay. So in a time problem, negative time usually does not obviously fit the context, right? Time is not negative. If t is equal to 0 represents the start of the situation, then t equals -1 means 1 unit of time before the situation began. So we reject t equals -1. Okay. All right. So if, and for the record, if t equals 0 represents the start, t equaling -1 means 1 unit of time before the start. So we reject it. Okay. Obviously. So t equals -1 is rejected because we cannot have negative time. Okay. Um, and the most valid answer obviously is t equals 5. Okay. T equaling 5 is more valid because quadratic equations may produce two algebraic answers, but applications require us to interpret the answers to make it make sense. So in the case where we had earlier a negative zero point 0.1 in terms of time and a 3.1 in terms of time, we're going to reject this one and then use that one because that one is the one that makes the most sense. Okay, the final review is, remember, these simplify to I, and then if you have an I squared is simply -1. If you have a constant in there, you can simplify the constant. Remember, use things like the factor tree, and also extract the -1, making the I appear on the outside of the radical for numbers that are greater, for a numbers that are greater. Remember, the discriminant is going to give you complex solutions, very complex solutions, and those complex solutions or um, simply occur when the discriminant is less than 0. Okay. In applications, always make sure the answer fits the context. Okay. And again, thank you for watching.